Okay, so like I mentioned, so like I mentioned, before now, MPLS before SD-WAN, which is software-defined wide area network. The essence of this is to be able to introduce intelligence into the wide area network. We said before that MPLS was used for wide area network communication between maybe the DC and other branches. You understand? And before, organizations and enterprises used to have their backhaul in their DC, so that make it a private network for all the branches and DCs to communicate within the same LAN, which is not exposed to the network. But the issue with this is that they are sometimes expensive, they are slow, they are not as intelligent before. So there are two major things that SD-WAN is very important. Two major things when SD-WAN was introduced. The first thing is to be able to to address internet access, internet experiences for users. So for instance, let's say organizations have two internet links like we have here. So before there's no little to less intelligence into routing users traffic to the best performing link before. So they either use one of these ISP link one at a time, or they make one backup and one active. So what means that when this one fails, that's when this one will come up. You understand? And there is no metric to measure the performance of this link. Okay. So for instance, now an internet service provider gives, let's say Acme. This is an organization called Acme. They give Acme internet service, and they've signed an SLA with Acme. SLA means service level agreement with them that will be giving you certain uptime, certain latency, jitter, packet loss. But Acme does not have, the resource to measure what, these ISPs are giving them. Yeah. And this is where SD-WAN comes in. So SD-WAN can measure the real, internet quality, real-time internet quality of the link provided by these service providers to Acme. So now, SD-WAN now brings in the intelligence of measuring the real-time quality of this internet link. So for FortiGate, or Fortinet, let's say Fortinet, the way Fortinet does it is that this FortiGate would, for SD-WAN technology of FortiGate, will begin to measure the real-time quality of this link in terms of latency, jitter, and what? Packet loss. Packet loss. And with these two links provided to Acme don't have to make one necessarily a backup or an active link. The two cannot be used concurrently by all the users or servers that has been provided. So let's say the first link, maybe this service provider provided, let's say 20 megabytes per second. 20 megabytes, per second, Mbps. And the second one is 30 Mbps. It doesn't mean that these two will be combined for one user. It doesn't mean that these two will be combined as 50 Mbps for one user. It means that these two can now be used concurrently by all the users or servers. Are you getting me? Which means that these two ISP links are now made available to be used depending on we call it algorithm by the ISP. Don't worry about those, but just understand that these two can be combined and be used by all the users, not by but one link will be used, per time, per users or per devices, depending on the algorithm being used. But where everyone now comes into place is that it can now intelligently know the best link based on latency, based on jitter and packet loss, so that users trying to visit a particular site can use this intelligence to quickly route traffic to that site. Are you getting me? So without delay. So necessarily, this guy doesn't have to fail. ISP2 doesn't have to fail for ISP1 to kick up when. So the essence of that SD1 is that for the first use case, these two ISPs can work, internet, link can work, concurrently, and the best part to internet resources can be used, by users and all that, and it's dependent on the latency, jitter, and packet loss for the real data. So this guy, ISP1 or ISP2, does not have to be down completely before the traffic can be routed to another link. You just have to exceed a certain threshold that has been configured on the device. So you can set this threshold on the device, on the FortiGate device, that okay, latency should be maybe the threshold for latency should be maybe let's say 100 milliseconds. Jitter can be maybe let's say 5 s, and packet loss maybe 2%. So this threshold will be put into consideration, for the two ISP, and the device here, FortiGate, will continually monitor those things and test them based on this, threshold we've set for them. So if any of this link exceeds and this threshold with configured, you call it performance SLA. If any of this link exceed this threshold based on what we've configured, the user's traffic would automatically, switch to the best performing link, that has not breached, this threshold. You understand? So this is what the SD1 has now intelligently, introduced into the enterprise, that you don't have to, let one link be down before the second link comes up. You don't necessarily have to make one a backup link or an active link. The two can work together, and there's a lot under SD1. We have the SD1 cruise, where you can play with the SD1 what's it called, strategy on how to go deeper on that. But the understanding is that these two links, for the first use case, these two ISP links can be used concurrently for best performance, for real-time monitoring of those things. And you can always get reports, for the historical data of this quality of links at the end of maybe the month or something, so that you can use it to benchmark what the internet service provider has signed up as SLA for Acme. Do you understand? So that's the first use case. The first use case is that these two links can be used concurrently, and the quality of the link can be measured and monitored in real time, and user experience can be better, because once we have this intelligence in real time, they can always switch back to a best performing link for the users trying to have access to the internet. And the internet links can be used concurrently, like I mentioned. So let's say this one is from Fiber1 and this one is from MTN. You understand? These two can be combined on device and can be used for the internet for the users. That's first use case. You get that? So the second use case is now where we have data center branch, communication, whereby we have a data center or we have an HQ, and the branches needs to communicate, with the data center or HQ, or maybe there's a server or data that they need to interact with at the data center. So instead of using the MPLS link, sometimes what we've seen recently is that because of the introduction of SD1, organizations are now limiting the usage of MPLS. Maybe there's an organization using 3 MPLS links for redundancy. They're not limited to one. So they will now combine. So they will now combine instead of using 3 MPLS links. They will now change the MPLS links twice to internet link. So now let's say this is the LG. This is the FortiGate by the DC. So now instead of using 3 MPLS backhaul system at the DC and all that, which is heavy, expensive, and not actually flexible as in the modern day SD-WAN. They will not change it to 2 ISP link and 1 MPLS. So we have 2 internet links. So ISP1, ISP1, ISP2, and MPLS link. So this MPLS link still provides them a level of redundancy for private links, like I mentioned the other time, whereby they have to connect all the other sites together so that they can be able to communicate over those links. That's a private link. So now, the concept of IPsec VPNs now applies here. Like before, we talked about site-to-site VPN, which actually uses encrypted tunnel, So this is actually one of the concepts that will be used, for communication over the ISP links for SD-WAN. We'll talk about it. If you don't understand anything, let me know. At least they get up. Yeah, they get up. So now what will now happen over here is that this is a DC. So there's a FortiGate device at the DC. You get. We want to introduce SD-WAN. You understand? So now, maybe before they're using multiple MPLS. Now we've told Ahmed that, okay, use SD-WAN, Fortinet SD-WAN. So instead of paying heavy on MPLS link, you can leverage on your existing ISP internet links, and just maybe retain one MPLS link for the sake of redundancy and failover. You get. So what will now happen is that Ahmed listened to us. They retained their 2 ISP links. They are working very well. Maybe one is Fiber1, the second one is MTN, and they have 1 MPLS. So we now told them that for you to enjoy this, let's say we have FortiGate 701G, LG 701G at DC. You understand? So we now say at your branches, we have multiple branches in Lagos, in Abuja, and in London. So we say at this Lagos office, you need a FortiGate device. This FortiGate device will be maybe one of the smallest one, depending on the number of users in this site. Let's take it as 68. No, let's use 91G. It's a model of FortiGate device, 91G. Let's say at the Abuja office too, we have 91G. Yes, sir. This is a FortiGate device. At London office, we have 91G. Yes, sir. So we have 91G across each branch and a 701G at the office. So the concept for SD-WAN, between communication between the branch, we use under SD-WAN, that will be hub and spoke communication, which means that this LG at the DC will act as a hub, right? Yes, sir. Then this one is the device here. There's 1G in each are called spoke each. So this spoke. Okay. Spoke. Spoke. Go and learn more about hub and spoke. Hub and spoke. So the idea here is see that site-to-site tunnel we talked about. Site-to-site tunnel means that we have 2 sites. Yes, sir. And want to achieve wide area network. Instead of using the MPLS we talked about, so we have 2 devices. Let's say we have FortiGate devices at this location, and we have FortiGate device at this location, and each device has, internet service. So over the internet, you can create an IPsec communication, an IPsec tunnel, so that users here can communicate to each other. This is the concept, and this is now encrypted. You understand? The tunnel is encrypted using IPsec protocols. It's more secure. It cannot easily be breached because of that the encryption. So user here or client here or server here can now have that level of communication across different locations because of the IPsec communication with connection with. So it's the same concept we will now use, for the SD-WAN, for the Fortinet SD-WAN. So here we have what is called, there are terminologies that you need to, familiarize yourself with. We have overlay tunnel, overlay link. No, we have underlay link. There's what we call underlay link. And that's what's called overlay tunnel. Overlay tunnel or overlay link. So
that IPsec tunnel be also the same as, can I also classify it as a site-to-site VPN?
Yes, it's in the site-to-site VPN. Yes. Any communication over wide area network that's between two gateways or two L3 devices, and you've been able to encrypt them, then it's called site-to-site VPN.
Okay.
You understand? It means that I'm in Lagos. This device is in Lagos. Another device is in Abuja. And you've been able to configure them to communicate with each other. You understand? Forming that tunnel and all that. That's site to site. It means there's communication between Abuja and Lagos over the encrypted tunnel. So that's site to site. So we are still using that same technology. We'll use that same technology here. So I want you to familiar with underlay link and overlay tunnel. Underlay link means that whenever you hear underlay means these are the original tunnels. These are the original link that is provided to us by our ISP service. So, like this one, this link connected to FortiGate are called underlays. You get?
Yes, sir.
Yeah, physical links.
Yes, sir.
So, FiberOne comes, they give us a CPE to connect to our FortiGate. That's underlay. MPLS connection to your FortiGate is called underlay. You get? At this place as well, in Lagos, in Lagos sites, you have 91G. You get? In Lagos site, we can have two ISP link or three ISP link, depending on the design or the what the customer can afford. So again, you can have one ISP link. That means ISP link. When I say ISP link, it's actually internet link. You can have access to it. Then we have MPLS link. So now you can also make it three. So ISP1, ISP2, and MPLS. They all terminated on the 91G. So the same thing will happen on this 91G in Abuja and in Lagos. So all these links terminated directly on the devices are called underlay. You understand? And that's the beginning of the configuration you are going to do an explanation. So now when we have this underlay, which is underlay, is on this underlay, we will now create the overlay tunnels. Overlay tunnels are what are the IPsec tunnels we created using the underlay links. So for instance, now we have ISP1, ISP2, MPLS link in Lagos office. We have ISP1, ISP2, MPLS link in Abuja office. ISP1, ISP2, MPLS in London office. So all of this is now what we now do is used as hub and spoke communication or connection, which this hub is receiving, those connections or initiations from the spoke devices. I get it. So Abidjan office can communicate and initiate tunnel and communicate to receive to access devices. All is mostly where all the data for the organization would be, their servers, their data. Is where all those things will be, and the device there will be the one, aggregating all those links, to give access to those servers.
Yes, sir.
You understand? So with this, what we now do is that now that we stored Acme, we use MPLS link. Just use one and use two ISP. So what we'll now do is that we'll for the SD-WAN on this FortiGate, all these tunnels will now be, they will be combined together in a zone, an SD-WAN zone, so that they can be used, together. And we now be able to create tunnels. We are creating tunnels, overlay tunnels using each of these link, to each branches. So for instance, now this tunnel, so let's call this one. So now, as one ISP2, ISP1 and ISP2, we use this, create tunnels on them each individually, so that as soon as we create tunnels, overlay tunnels with them, one, they are encrypted, and the way we are able to measure the real-time quality of the ISP links using latency and jitter packet loss is the way we can now begin to measure the quality of those overlay tunnels that were created. And so now these overlay tunnels we created will now be linked to each of these, funnels from the ISP links. You understand? So from Lagos site, since they have 3 links, now they can have two tunnels and 1 private links. I get in it. Those 2 tunnels, don't forget the concept of IPsec connection.
No, sir.
So those 2 tunnels have been created and encrypted, and they'll be linked to connect to the site.
Yes.
So what will now happen is that using the performance SLA from each site, we can now measure the quality of these overlay tunnels we've created, to a server. So we can monitor one server. I'll show you on the device when we start, when we log into the device. So we can now begin to measure, the quality of those things by trying to, continually monitor the route to one of the servers at the HQ. So that one will give us the real-time quality of the latency, packet loss, and jitter of each of those tunnels from here. And so for each of these devices, we've been able to create overlay tunnels to them. So, and with this intelligence will now be introduced to all those links and tunnels, so that anybody coming from Lagos,
Yes, sir.
will be able to. So if a user is coming from Lagos and wants to access the server here, the device can determine the best performing links between the MPLS private link and the tunnels that were created, to be able to route them to the servers we have here. So each of these devices are part of the SD-WAN, system, to ensure that users' traffic are properly routed through the best performing link, to the hub and to the servers that they are here. And all these things can now be, they can be configured. We have what is called FortiManager. This FortiManager will sit at the hub end. So the FortiManager, we can use the FortiManager to build templates, build the IPsec template, SD-WAN set template, even the device initial configuration template and all that. And all this can now be pushed centrally to all the sites. So you don't have to configure this manually. So FortiManager will be the one to build up the template for us, build up the overlay, tunnel properties, components, and all that. And with that, we can push them, centrally to them. And the Forti Manager is just for, orchestration, for policy configuration, template building and all that. But the real CPU, the real device doing the SD-WAN, activity are the CPs, we call them CPs, are the FortiGate devices at each branch. Even if this Forti Manager is out of bound or is not reachable, these devices are still functioning and they can be able to. And the beautiful part of it is that, I told you that modern technology combines both router and firewall on the same thing. So with this, users in Lagos, Abuja, and London will not have to rely on the security layer
Yes, sir.
for their users to have security when they are going to the internet. So they can be able to apply security locally. So in Lagos, you apply, your security locally so that your users will not have to come to the hub to have access to the internet. Since they have internet access there, and mostly why most organizations always prefer that they go through the rights because security is always at the hub. But with SD1, you don't need your secrets to really be at the hub because you always lay a lot of responsibility and resources on you. So you can break out locally at the branches, and security can now be managed and be interiors by the devices at this end. And that's how SD1 actually works with FortiGate. And with that, you can have intelligence in this device. Users' experience will be better because latency, packet loss, and jitter are being measured in real time. And the tunnels at which the users needs to go through so that they can be able to have best performing access to these servers can be determined locally at the FortiGate, and they can route their traffic through. So the advantage is that now each location now have 3 available link over the tunnels that they can now use to have access to servers and resources at the hub. Do you understand what this Java?
Yeah, I'm understanding. So like I understand how the 3 will have to now connect to the server through the overlay tunnel, and how securities can be distributed in 3 areas. How you can like configure the securities in each layer so that the whole responsibility will be on the hub. And
the aspect of Forti Manager is very important because imagine Acme has 100 sites, 100 branches, and maybe a data center. Without Forti Manager, it will be a very tedious work for the engineers to configure. So the Forti Manager will be a central, policy and configuration to configure all those things. It's just a template. Once you build a template for a site, you can replicate that template in the matter of minutes for all the sites. You understand? So I have videos for the configuration and all that you can visit, but I want to be sure that you understand that concept. And when you get to site, you won't have to be tricked. So in configuring SD1, like I mentioned, design is very important. So you understand that for any Fortinet device, for any design, you need FortiGate at the home. So you need to position how is the connection from the FortiGate or from the ISP to the FortiGate at the hub. Then the Forti Manager has to be reachable. You have to onboard all these FortiGate devices. No, the first you have to onboard is the FortiGate at the hub and make one FortiGate from the brand. So I can build your templates and configure them. There is a wizard to configure that on FortiGate. So I don't know if I have any other question.
So what I was seeing high availability.
Okay.
So like I was trying to understand that high availability, does it mean that it's going to have 2 of that FortiGate in that hub site?
So where availability comes in is that when you talk about high availability, it's just a form of having HA, redundancy.
Okay.
So high availability are mostly in two mode. We have active passive or active active. Are you aware?
I've heard of it here.
You need to go and read. It's in that FortiGate operator. Active, passive, and active. It just means that though there are two FortiGates, but they are still acting as one. Most especially this is active passive.
Okay.
It means that, let's take this example. So it's just design that will change. Not design will not change, but the components will be added. It has maybe a switch or something. So we have two FortiGate now. So let's say this one is active and this one is passive. So they are connected together.
Yeah.
They have a link, a chain.
Okay.
This link that makes them being a HA. It means that when this one fails, so there will be an health check happening within this link. It means that there's a particular amount of time that this guy will be checking. Is this guy responding to it? Is he alive? If this guy is not responding within that minute or time, he gets. So if you now collect like all those traffic from him and send it to this guy.
Okay.
You understand?
Yeah.
So it's still one device working. It's just that when this one fails, what happens?
It transfers to the other.
It transfers the traffic here. So if there's no HA, when this one fails, the whole system is down. So that's concept of HA. It means that this guy, they are working, they are two, but they have the same operation. When this one fails, or is not responding as meant to respond, it fails over to this guy. So all the traffic will now start passing through there. So it should have been covered in your design on how this would happen, so that when traffic is coming and this guy is no longer responding to traffic, it fails over to this guy. But it doesn't really change most of what we've spoken about on SD-WAN. So go and learn about HA, most especially Fortinet HA. It's part of that FortiGate operator, and the other ones I'm going to leave to you.
So one more thing. So DDoS. I was seeing DDoS. How
DDoS. What's DDoS? DDoS.
Bombarding of network to make.
What was the formula of DDoS?
Distribution. I can't remember.
Distributed denial of service.
Yeah, distributed denial of service.
So what was the aim?
The aim is to make sure that the network is not available, like to make sure that like bombarding of the network, so that of traffic on the network, so that.
That's why I say you should understand concepts and things. Okay. So you're correct, but not entirely correct. Okay. So when you say DDoS, the aim is targeted at web servers for application or servers, so that server or application can never receive, authorized traffic. You get?
Yes.
So there are traffic that are authentic, that the server is meant to respond to. But when distributed denial of service is going on, you won't be able to respond to the authentic traffic, and it will make the server unavailable. The idea is to ensure that the service or application is not available for the rightful owners or for the users. So what FortiDDoS will do is that it will begin to filter. So I will show you, just an example of what we'll be talking about. I've done some videos on the two major use cases for the Fortinet SD-WAN. The first use case has to do with the ability to combine two ISP internet service provider together and use them, concurrently, and you can be able to route users' traffic to the internet for the best, internet service based on the quality of that service. And then the second use case has to do with communication between data centers and branches over overlay tunnels, and the ability to use those tunnels concurrently. measure their quality of of service and all that. So I've done that. I'll just show you examples of this, but so that for the sake of what we've done on the whiteboard session. So when you come to login, this is a spoke router. Like I mentioned, we have hub and spoke, and this acting like a spoke device. You understand? So if you come to network and you go to SD-WAN, you will see SD-WAN zones, SD-WAN rules, and SD-WAN performance SLAs. You can see the zones that has been created, 1, 1, 1, 2. So all these under SD-WAN zones, most of the things you would see there, about the overlay and the underlay links that was configured. This was actually deployed using the FortiManager. You can go and check the other videos on how it was configured. So we have 1 which is the ISP link for the first internet, and 1 2 as ISP link for the second internet link. Then we have the overlay tunnel zone, which are the tunnels we created using the ISP links and all that. So these are the overlay tunnels that is connecting to the hub. And but where I'm going is actually the performance SLA. So under the performance SLA, we have each performance SLAs for each threshold we are trying to monitor. So for instance, we set a threshold, monitoring the performance of those links when they try to connect to Google DNS. We can use Teams DNS or any internet server to measure those links. But here we have we are using Google DNS to measure the quality of those links. The second link is down, and we are seeing the quality of those things for the first one. So you can see packet loss for this is 0, which is measured in real time. You can see the latency is 36, and the jitter is 20, which is actually high. Assuming we have the second link and is lower than this, we can be able to define our SD-WAN. So if you come back to here, if you look at this, you can define the server IP address, monitor using protocols like HTTP, DNS, ping, and active. There's a lot of explanations that needs to be done here, which we won't do here. So we have target SLA targets, which are the threshold we are going to set for those links that you're trying to monitor and measure. So we have 15 ms, 15 and 0 that we've configured. This can increase, or it can increase them depending on what you're trying to monitor and what you're trying to achieve. And link status is the intervals at which the link actually fail over to
the latency checker, like the numbers there, are they constant, or you can choose, or are they certain numbers that we're supposed to put there?
No. You can. So for they are not constant. So for instance, if you put Teams server here, you get, and you can say the threshold at which this link should exceed for maybe Teams server or any other server before it fills over. Let's look at Microsoft Teams. So if you look at this, 1 minute. So if you look at we have network performance threshold targets. So let me look for performance threshold latency. It actually means that if you're monitoring, let's say Microsoft Teams or Google, it's saying that what latency, what quality of latency or data can this link endure for Microsoft Teams
before we begin to see decadence in our traffic. You understand? So if I'm using Microsoft Teams now, and I'm starting to get maybe breakage, maybe someone is not hearing me or something, what latency will it get to before that, that begins to happen, that decadence begins to happen and all that. And that's what we want to set. So if we can, if we can get to maybe 50 milliseconds and we are not breaking, if it is 50 milliseconds, will Microsoft Teams start, underperforming when we're trying to use it? So that is the threshold we want to get to. Okay. You understand? So we are trying to monitor that threshold. And here we can see that for great Microsoft Teams performance, aim for less than 100 milliseconds. You understand? 50 milliseconds one way, 30 milliseconds for Jitter. So in our performance SLA, we want to put if we want to try and use Microsoft Teams as our performance SLA, we want to use for latency threshold, we want to put maybe around 80 milliseconds for latency. You understand? We'll put maybe 20 milliseconds for Jitter. Then packet loss will put 1%. So now we can go back here and say, let's do Microsoft Teams. So what's the server IP? A server, is it teams.microsoft.com or Microsoft Teams.com? Is it Microsoft Teams? No, teams.microsoft.com. We get. Then let's call it Teams. Then based on the data we have here, we'll say latency should be 80. You get 80. Threshold should be Jitter should be 20. Then packet loss should be 1. Then we want to specify participants, which should be our internet links, which is port 4 and port 5. Then we leave every other thing as default. Click OK. But majorly, you use FortiManager to configure this, which is in another video. So if you look at Microsoft Teams here, you can see that packet loss is good. Latency is still under control, but the jitter is very high. You get, we have 20 as threshold. So this link is exceeding this threshold. Assuming we have the second link and is within the threshold we've configured, this FortiGate device would prefer that one better than this for your internet access. You understand? And these two can actually be, the two links can actually be used the same. So it's under SD-WAN rules, we begin to set for where we want traffic should be flowing. So for instance, for internet access, this for internet access and this for servers in the upside. So for this we have all address source as all. That means all internal network within the destination is all internet IP addresses and all that. And another thing is that you can actually define, use built-in application signatures to define traffic. So that's what MPLS cannot do for you. By using the actual application signatures like Microsoft Teams, Offices, Zoom, and I can use them specifically to define your traffic. Okay. Instead of using addresses and all that. Okay. So we can use that to define our traffic, but let's just use all. Then under here, now this outgoing interfaces talks about interface selection strategy, manual, best quality, and lowest. These are another topic for another debate. For this sake of this, we use best quality, and best quality will be based on required SLA targets, our measured SLA, which is our teams. You get. Then quality criteria will be based on latency jitter, but let's use jitter. We can use any of these quality criteria for that we set for those threshold. So we use Jitter. Then every other thing has been selected. You select OK. This can be moved up and down. So we have this, you see. And by the time you are done here, you begin to see which link is being used currently for internet access. And this is port 4, map as port 4. And the same to traffic to your hub and all that. And when you come to this SD-WAN zone, you can now see the real-time download and upload speed of your internet link and all that. So all these things are in a playlist, SD-WAN playlist that I did. I don't know if you have any other question. Okay, thank you.